So yes, my name is Dr. Julia Kazmaier. I'm a research fellow at the Kathy Marsh Institute in the UK Data Service, where I lead the Computational Social Science training team. And that's probably relevant because today we are doing an introductory workshop into what is computational social science. So moving right ahead, I will distract you with some information about other events you might be interested in. We've had some recent events, Pi Data Manchester and UKDS, Data FAQ discussion panel. We've had Data Management Basics 1 and 2 on the practical and the ethical issues of data management and sharing, Smart Energy Research Lab. All of these are available on our website, ukdataservice.ac.uk, under the news and events, past events. So it's fairly logical, but there's a bit of a nested structure there. We can also find upcoming events, slightly less nested because it's our website, news and events. Upcoming events include a webinar series and a code demo on what is synthetic data that starts on the 18th of May. We've got an introduction to the labor force survey and annual population survey, that's on the 20th. And every second Tuesday of the month, we have the CSS drop-in sessions. Our next one is on the 8th of June because we just had one earlier this week. And what that is, it's a very informal chat, usually about 8 or 9 people who come together and just have a discussion about computational social science questions they're having or research projects they're heard of, or, like this time we got into quite a long discussion about whether we could train an AI to recognize people's reactions to pottery stamps. Because there was a researcher wondering, like, how do we capture whether people are disappointed that things are not made in Stoke? Very abstract. But yeah, come to those. Okay, so now to the nitty-gritty of this workshop. Here's a brief table of contents. We start off with what is up with computational social science. We then answer the burning question, how can I become a computational social scientist? And we go through an interactive sort of project development section with the 8 steps of computational social science. And then we have time at the end for questions, and maybe people can share what they've learned or what they still want to learn about, and then I can point you in the direction of some resources. So there's lots of time for interaction. Please do not be shy about asking questions in the Q&A. And here we go. So computational social science is the use of computational and empirical methods to address social science questions. Now, this is important because it requires human thinking in order to identify the important research questions. You have to know how to think like a person in order to ask good social science questions. But you need computer thinking to turn those questions into computational empirical methods. And then typically you need human thinking, again, to turn the results back into effective science communication, policy recommendations, publications, conference presentations, all of that. So it's a little bit complicated. You need multiple kinds of skills. Importantly, computational social science is not just using computers within social science research projects, using digital versions of purely traditional social science methods, or using digital but purely non-empirical methods. And we'll go into this a little bit more, so don't worry if that sounds like a bunch of gobbledygook. So let's have a couple of examples to start off with. So a CSS project might collect, process, and analyze millions of online news articles in order to show changing political attitudes. This is something that I have actually done. Use real-time weather and traffic data to show how travelers react. This is not one I have done, but it's one I'm interested to do. You might combine data from novel wearables or apps to establish correlation between social media activity and heart rate. That's quite a speculative one. I have no idea if anyone's doing that. Or you might import, process, and format centuries of parish records in order to map family names over time. That's also a speculative one. I just pulled that out of thin air. If anyone wants to do that research project, let me know. In essence, CSS is an opportunity to do socially valuable research that would not be possible without computational methods and tools. So that's why it's important. We could arguably get a bunch of like interns or students to read all of those parish records and write down the names and what years they're there. And, you could put that into a database and you could theoretically make a map, but nobody has that kind of time or money. But you know what? Computers can speed it right up. So it certainly becomes possible within the sort of time and finance restrictions on research projects. That's why we need computational social science. Now, there's some key factors that capture what it is about socially valuable questions and also about computational methods and tools. So typically key factors in computational social science boil down to data volume, complexity, the speed at which it's created or updated, the difficulty of the data or the novelty. This is more important than the exact data source or type. So in the previous examples, we saw online news articles, wearable apps, weather tracking sensors, parish records. All of these things are different types of data, different sources. But what makes them computational social science is that the volume, the complexity, the difficulty, the novelty, that's what's key. Second, the data must pertain to people and their actions, behaviors, choices, statements, that kind of thing. So it's wearables on people. It's data and transport weather about traveler behavior. It's, parish records about births and deaths and names, that kind of thing. And the exact research question is not specifically important. Obviously, it's important to the research project, but not important to whether or not it's computational social science. But it must be a social science question. So it has to be about how people react to their environment, or how people react to online behavior, or how people move around over time as part of economic and social changes. So these are the key factors. So now we have come to some interaction. I want you to vote on whether you think this is a computational social science research project. So the options are definitely, definitely not, or and what it is a research project that scans historical records and uses AI algorithms to recognize text, identify ingredients, and measures used over time. So far, everyone agrees that this is absolutely computational social science. Ooh, a couple people not sure. Someone says definitely not. And I will say at this point, there are not absolutely 100% yes or no questions to this. It kind of depends on what the questions are. So are they trying to identify ingredients that were available in like a environmental ecology sense? Or are they trying to identify the ingredients that came in and out of fashion in sort of cultural changes? Arguably, that might make the difference between this being computational social science and this being like, I don't know, historical ecology or something like that. But I think most people are either not quite sure or agree it's CSS. I'd be interested to know why someone says it's definitely not. That might have just been an error, or maybe someone feels very strongly. Moving on, we've got another one. A research project that seeks to understand how people interact with smart home technologies by using gamified smart home displays. So far, we've got a definitive yes, it's CSS. Ooh, some not sures, some definitely. This one I think is maybe a bit clearer, and that's reflected in this breakdown of answers. I think this is definitely CSS, because it's it's asking questions about how people behave. It's using gamified smart home displays. In theory, the gamified smart home displays are what's recording the data, and therefore that's a sort of an app or a technology. You would need computational means to get a hold of that data. It would probably come in huge volumes that we'd need computational methods to manage. Got a couple more of these. A research project that advertises for survey participation on social media and that stores the responses in a big database. Ooh, I think this is good. So we've got some definitely not CSS. Yes, this one I put in purposely to capture the idea that you can use very, very traditional social science methods, but digitized versions of them. So it's an online survey, but basically it's a survey, and a survey is not inherently CSS. It could become CSS if you were trying to capture like millions of people. Once the questions, like, it would also have to be about social science questions rather than like, I don't know, technology questions or something like that. But yeah, I agree. I think this one, the way it's written, probably not CSS, or at least not clearly CSS. Very good. I'm liking the learning we got going on here. A research project that reads in real-time weather and air pollution data to create complex models of air quality. Ooh, yeah. So this one, another sort of tricky one. I did, I talked previously about how real-time weather and traffic data would be a CSS project. In this case, it's real-time weather and air pollution data, but it's modeling air quality. So unless you were specifically asking how air quality affects people's choices or behaviors or patterns, this is probably not a CSS question. So very good. I'm liking the donuts here, showing how people feel. Last one, I think. A research project that trains neural nets on social media posts to see if they can create posts that counteract online radicalization trends. Yes, people seem, you know, quite confident that this is almost certainly CSS. I agree. Training neural nets is an AI kind of approach. So that is definitely a computational method. Social media posts and radicalization and trends are about people and their behaviors. So we did get a couple of questions come in during that time about some of the previous ones. Lorna, for example, early on, she said she's not sure, there was no research question. The scraping gives you the data, but not the analysis interpretation. That's very accurate. Like, some of these descriptions of projects didn't specify what the research question was. In theory, they could have had a social science research question. So you're right. That's why I gave the not sure as an answer. And Gloria, probably in relation to the air quality and pollution and weather, talked about maybe if you linked it to Fitbit, and if your question was about how does air quality affect people's exercise behavior, yes, that would turn that into a CSS project, because that then becomes asking about how air pollution and weather affects human behavior. But if you're just trying to model the air pollution as a physical sort of spatial occupier, then it wouldn't. But you're right. A lot of these questions could be interpreted as CSS or as not CSS. Very sharp. I'm really liking this. So now we're going to take 5 minutes. Just, it's maybe a little bit early in the process, but if you want to have a stand up, get a drink, take a comfort break, if you're happy to keep going, then now is a good time to interact in the Q&A on Zoom. We can continue talking about some of these examples. Maybe you can also tell us about some CSS research that you've heard of or thought about doing, or in fact, any other projects that you want maybe to discuss about, like, is it CSS? Is it not? So just 5 minutes to take a break and or a discussion. I'll be here the whole time, so don't worry. So let me just clear up these ones that I have answered. An anonymous attendee has said, a lot of these answers have a clear machine learning aspect. Can CSS encompass the methods of analysis? Does it become computational once you use something other than Excel? Now that's an interesting one. I used a lot of machine learning examples because that's what I've been working on recently. And so that's what's on the top of my head. And it was easiest to take it from the top of my head and put it into the presentation. CSS does not have to be about machine learning. It could be computational social science, and you can still use Excel to analyze it. So it's not necessarily about the specific tool, but probably if you're using so much data or such fast moving data or such complex data, Excel will not be a very good tool for it. Excel does have a limit of 1 million rows, I guess. That's famously known as the 1 million rows problem in Excel. And so it could be used, but it's not the best tool, Excel. That said, there are absolutely lots of other ways to get and analyze and work with data outside of machine learning. Okay, we've got a question. Ali asks, I wonder what the key subject disciplines are that use CSS methods. I know psychology uses a lot of computational and empirical data, like psychology experiments often use, sort of gamified things or sort of online interactive activities that it then records, the speed of reaction, the choices they make, the series of choices in what order and how that affects final outcomes. Psychology is right up in it. I think criminology, as also obviously because the subject matter encompasses things like radicalization or online bullying or stalking. Criminology has really opened up to computational methods, and so those are two key subjects that I can think of. But if anyone else knows of any, I'd be happy to learn about other social science disciplines that are really diving into CSS. Okay, Mary asked, what is the difference between a computational social science, a machine learning scientist, and a data scientist? Also, where do computational social science work? First off, I'll say computational social scientists probably work in boring little offices in weird corners of the building. It's not a discipline that necessarily, as of yet, has its own department, has its own sections. So there's probably people who could be called computational social scientists stuffed into every department as and when they happen to have interest in these methods. But the important question here, what's the difference between these things, computational social scientists, machine learning scientists, and data scientists? And I would say that's about the research questions that they're addressing. Computational social scientists are specifically addressing social science research questions, whereas machine learning scientists might address social science research questions, but they could also just be learning to optimize the machine learning process. So they could be computer scientists. They're learning more about how to build algorithms and improve algorithms without really considering at any point how those algorithms are applied to social scientist questions. And data scientists, likewise, they can be understood as working on social science questions, but not necessarily. Lots of data science scientists will be working on how to create new data science tools, techniques, methods, applications, how to improve existing ones, with the research questions being about the data science, not about the application to which that data is put. So I hope that answers the question. Keep it coming if you think I haven't captured something. Here we've got an anonymous attendee who says, I work in the area of social simulation, agent-based modeling, and I'll give you a big thumbs up because that's one of my favorites. We call this computational social science, and rightly so. But CSS is more widely used to refer to big data, machine learning, and AI in some cases, and social science research questions. Is there a widely accepted disciplinary agreement on what topics areas fall under CSS? I would say no. CSS does include modeling and simulation, big data, machine learning, AI, gamification, virtual reality, motion capture, all kinds of things that are a bit like out there science fiction-y in some ways. What unites them is that they are applying these methods to social science research questions. So that I don't think there is a widely accepted disciplinary agreement on what topics fall under CSS. It's basically if it's a social science research question and does it use a computational or empirical method that you couldn't do without computational tools. Hope that answers that. But again, thumbs up for agent-based modeling. One more. Some of the examples were what I think of as digital humanities. Is there an overlap or divide? Now that's an interesting one. Digital humanities probably is another term for computational social science, but in the way that humanities and social science are clearly linked, but not necessarily synonymous. So digital humanities might uncover a lot more sort of art and cultural explorations, but that aren't seeking to make sort of to answer a question through a scientific method. So yeah, there clearly is a lot of overlap. And I think the divide is about whether you're trying to answer a research question through the scientific method. In that case, it's probably computational social science as well as being digital humanities if you see an overlap there. Yeah, we got some questions about the historic ingredients research not being CSS, not linked to human behavior. Yeah, kind of, it depends on the specific research question. A lot of these things were meant to be a bit ambiguous. Yeah, good discussion. So I think that's our time up. I'm going to proceed with the workshop. Please do keep the questions and/or chat comments coming. So, how would you summarize CSS? Following that discussion, you can enter up to 3 terms or phrases or suggestions in Mentimeter, and this will create a word cloud. So, we'll get to see how much of this discussion has led to agreement or disagreement, which is fine too, because we're social scientists. We study disagreement as a topic. So go ahead and enter into Mentimeter 3 suggestions. Oh, we got some coming in. Human-centered and computer-assisted. These are both very good. That's true. Yeah, people, automation, high speed, empirical. Yeah, this is great. You guys all get gold stars. It is about, fundamentally, it's about doing social science research on people using machine computational tools and empirical methods that you wouldn't be able to do without sort of modern computers. And if we think about that critically, just imagine the crazy computational social science stuff that will be available to us in the future. The future of social science. Yeah, timed up quite well. Complexity is good. Technology, systems thinking, interdisciplinary. Yeah, you guys are really on it. Fantastic. Great. Okay. In that case, I will give this just another second to see what comes in. I'm liking this word cloud option. By the way, there will be a survey at the end of the workshop. Please do let us know about the contents of the workshop and also the tools we've used. If you really like Mentimeter or you absolutely hate it, let us know. Robot social science. I like that a lot. Turbo powered. These are great. I'm loving it. I gotta move away because I can stay here all day. Okay. So now we're back into the workshop, and we're approaching the question of how do I become a computational social scientist? So we start off, I assume most of you are social scientists, which is a common place to start when asking, how do I become a computational social scientist? So social scientists have a lot of really useful skills. They think like people. They have experience in studying people and interactions and behaviors, and these are very difficult things to study. Their thinking skills include abstraction and inference. They have a intuitive grasp of fuzzy categories, all the discussion about overlap between digital humanities and computational social scientists shows that you really understand things can overlap and be on different spectra at the same time. Really good use of background knowledge. That social scientists do have data skills. This is important to recognize. They are very comfortable coding responses and categorizing different kinds of people and groups and responses as well. They have experience evaluating the quality of their data. They have experience in pattern detection and creating visualizations and analyses. Social scientists do use computers because we live in the modern age and everyone uses computers. But most social scientists do not write computer code, or at least they're not very comfortable or experienced in writing computer code. In the meantime, sort of computer scientists, data scientists, or the other group of people that might want to become computational social scientists, pardon me, they think like computers. So they solve information and processing problems. Their thinking skills include a good grasp of concrete definitions and absolutes, strict hierarchies and categories. This is as opposed to the fuzzy overlapping categories. Clearly defined and scoped variables. Scoping a variable is tricky. They understand rules for behavior and things like that. And they also obviously have data skills. They collect, analyze, manipulate data through programming scripts, computational methods, technological tools. This is old hat. They're not worried about it. They're not usually taught to identify or motivate research projects with societal impact or value. So that is, they're taught to identify research projects that have an informational processing value or a computational advancement value or something like that. They don't necessarily have a lot of experience saying like why this research matters or who's going to be affected by it, or any of those kinds of questions. Those are social science questions. So what does it matter? If you want everyone who comes into computational social science, be they social scientists from originally or a computer scientist originally, they're going to want to build up their human thinking skills for identifying important problems and knowledge gaps, considering possible solutions, connecting problems to relevant theories and perspectives, which is quite a hand-wavy thing that's hard to do, collecting relevant information, and research to frame the approach. And I'll tell you, it is not necessarily easy to build human thinking skills. It's easy-ish for social scientists who are trained in things like abstraction, communication, context, shared knowledge. It is harder for computer scientists or data scientists who are not trained in using ill-defined, overlapping, context-dependent concepts. They're not trained in using assumptions and background knowledge. In fact, they're trained not to use assumptions and background knowledge because computers are terrible at using assumptions, background knowledge. And so in order to work with computers, computer scientists are often trained to ignore context and background knowledge. There should have been some slides there. They might have moved around about how easy it is for for social scientists to gain computer science skills. Let me just, here we go. So if you come from a social science background, especially, you'll want to improve your computer thinking skills. So things like accessing, organizing, processing vast or complex data, writing collaborative code, collaborative is a keyword there, and documenting workflows. These are computer thinking skills that social scientists may struggle to acquire. Now, it is easy-ish for computer or data scientists trained in computational methods, rules, definitions, formal processes to learn these kinds of things. Not necessarily that they already have them. Certainly documenting workflows is something that everyone can benefit from improving. It is harder for social scientists because they're so used to using background skills and sort of fuzzy categories. It is very hard for them to learn how not to do that on demand. But they can build on the coding responses, the formatting surveys, the statistical analyses experience that they have, among others. Obviously, everyone starts out in a different place in terms of their experience and their comfort with thinking like a human or thinking like a computer. Also important to CSS, if you want to become a computational social scientist, be open-minded and eager to learn. No one starts out with all the skills they need. In fact, no one ever acquires all the skills they need, because you need all of the skills ever, and who has the time? No one knows all the skills that they might need to acquire. So in advance, this is the relevance paradox. You don't know what you need to know because you don't know it. It's a conundrum. Don't worry about it too much. But approach the research project with an open mind, curiosity, willingness to learn, and other like tree hugging qualities. It'll be good. Some skills will be easier to pick up or use than others, and this will be different for every person. Some people will find documenting workflows to be an unending uphill battle, and other people will say, nope, got that. But you know what, this scoping variables thing, I just cannot get it. It's okay. Don't worry about it. You can't do it all by yourself. This is because no one ever acquires all the skills they need. So be prepared to collaborate. Another key point to becoming a computational social science is pick a mixed thinking problem. So we discussed some already. In fact, we discussed them quite extensively, but there will be many more as resources become digitized, interactions, objects, processes become smart or network connected, large volumes of data are made available or updated at faster rates. And in fact, other things happen in the future that we can't really predict because we are terrible at predicting the future. But if you want to do a CSS, you need to pick a social science question that is well served by computational or empirical methods. And that's a mixed thinking problem. So, all right, this is where the slide should have been about. Let me just move back to it. So how do you do CSS in a practical sense? You follow my 8-step process, trademark pending. Broadly, they are identify the problem, explore the problem, formalize the concepts, collect data, implement software, and verify that software or the data. Experiment, analyze data, discussion and conclusions, communicate, publish, present, share, document, validate. Now that sounds all very easy, I hear you say. It's not. So let's move on to back through these slides that we have already covered. No worries there. Let's be a little bit clearer about what I mean by identify the problem. You need to be as clear and specific as possible about the pattern, problem, or lack of insight that your research question will address. Now, this is difficult for social scientists because being clear and specific is a little bit at odds with the sort of encompassing background knowledge, overlapping fuzzy category stuff that most social scientists are taught to do. So this will be right away, bit of a challenge. And before I go too far into this, I just want to address a couple of questions that have come up in the Q&A. What software does CSS use? Stata, MATLAB, Python. All of these are possible. There is no right or wrong software. I think Python is probably a more valuable one. Although MATLAB has its adherents. Stata, I've never used it. I don't really know too many people who I would not prioritize that. But not having used it, maybe that's just a fault on my part. And do you know of a good book that gives an overview of CSS, the background utility of it as a method? Yes, let me see. I don't know where it's got to. There are a few references at the end of the workshop, and I will also say there are things like ABM and GIS. There's a book called Agent-Based Modeling and GIS Mapping, I think. I hope I've referenced it. If not, I'll look it up. There is Automate the Boring Stuff. There is Programming for Social Scientists. These are a few texts, and I'll task Joe in the chat with maybe finding links to these kind of things. Yeah, it's a growing topic. So right now, there might not be the book that you want already, but it is probably being written. And it might even be written by me because I've got some things in the works. But yeah, there are a few books that approach this topic from slightly different angles that might be more or less what you're looking for. Another one that I actually wrote a couple of chapters on is agent-based modeling for socio-technical systems. And it actually works through a 10-step process, of which this 8-step process is loosely based, about how you use agent-based modeling. That's a particular method for asking good questions about complex systems like industrial networks or energy grids or political systems, things like that. But back to the identify the problem. So you've got to be clear and specific as possible. You also have to identify who is involved, where it is, what's the right level of granularity to be looking at it. You want to be basically as clear as possible about the problem, and that is not easy. Next, you want to explore that problem more deeply. So you want to gather information and perspectives about that problem in multiple ways. So that could be surveys, that could be observations, that could be secondary data analysis. You could create an app that sort of tracks people as they go about interacting with this problem. You could web scrape, you could APIs, expert interviews, literature review. There are loads of ways that you can get more information about the problem. Basically, this is sort of checking your insights about what the problem are with other information. So experts, historical data, that kind of thing. Make sure you understand what the problem is, who is involved, where it is, all that kind of thing. You want to spell out sub-problems, processes, important relationships, important actors, any simplifications or assumptions that people bring to this problem typically, existing specialities, that kind of relates to the actors. So if you're studying, for example, how people react to train delays, you'll really want to talk to people who run trains, people who maybe have brought lawsuits against train companies for poor performance, things like that. Now, back to the interaction. Aren't you just excited? You want to write down steps 1 and 2 for your own theoretical CSS project. Maybe you actually are working on a CSS project, which is great. But if not, just pick one of the examples we brought up earlier, or pick create your own example. You can ask or upvote questions in the Zoom Q&A or in the chat, actually. What you want to do at this point is identify the problem and explore, decompose the problem. Now, obviously, we're not going to be able to do this in a realistic way. Properly, computational social science projects take, months or years to answer properly. But I want you to get some experience thinking about how you might go about creating a CSS project and what it might look like to work through these steps. Okay, we've got a question from Kevin. In the process of exploring a problem, it's often easy to make CSS models more complex than they need to be. Are there any recommendations to simplify all along the process, have checkpoints when defining and modeling the problem? Yeah, this is a good one because you're absolutely right. And that's part of identifying the problem is you need to specify your level of granularity that you want. And in theory, a good sort of rule of thumb is you want one level above and one level below what you think the problem is. So if you think the problem is trains running late, you'll want to go one level below and maybe include individual trains, individual train companies, and one level above, which might be a national grid for trains. So something like that. Or if you think the problem is, people not exercising because the weather is terrible, then you'll want to look at individual people, groups of people, and then maybe like statistical categories of people quite widely, or even internationally, groups of people as nations, so that you can compare one nation and its typical weather with another nation and its typical weather. There is no right or wrong answers here, which kind of makes this difficult. Some people will definitely struggle. You kind of just have to make decisions. Where am I going to draw the line in who is involved in this? What's the right level of granularity to be looking? You just have to make decisions. But a key point to that is writing them down, justifying why you've made them, and making sure to revisit that on a regular basis. So if you find yourself wandering into a rabbit hole of looking too deeply at one subgroup of the problem, you can either restructure your problem to just focus on the subproblem, or you can say, you know what, that's interesting, but it's outside the scope of my project. I will make a note of why it's interesting and why it's outside the scope and leave that for a future day. Yeah, in theory, this 8-step process is a way to have checkpoints when defining and modeling the problem, because as you work through these steps, it will ask you to sort of look back on previous ones and maybe readjust them and work through them again. So for example, when you explore, decompose the problem, you might find your original view of what the problem is was too broad or too narrow or too skewed by experience or something like that, and you want to rewrite the problem, at which point you then go back through step 2, and you might find yourself looping around like this a bit. Ideally, it will get you somewhere. If you find you keep making the same amount of change each time you're looping through, rope in some other people, because it might just be that you're creating your own rabbit holes. Okay. Ali has read the paper I recommended before today and was interested in the distinction between accidental data and pre-planned data capture. Seemed to suggest CSS should have a planned design and research question. Can you give us a little insight on this? Yeah, I mean, we can have a planned design and research. Let me take a step back. In an ideal world, we would have plans for how we go about CSS. It doesn't necessarily have to be we start out with a question and then acquire data. It could be that we have some data, we see something interesting going in there, and therefore we have identified a pattern, and the question is, what is this pattern about? What's causing it? What determines its shape or function? So you could start with data and ask questions about it, or you could start with a question and find data that relates to it. Neither of these is wrong. I mean, in this slide, I say identify the problem, but that could very well be identify the pattern or identify the interesting behaviors or identify the lack of knowledge. And that lack of knowledge could pertain to data that already exists or data that we didn't intend to collect, but we find actually, we're tracking Fitbits because we're trying to get people's steps, but we also get maybe their steps in relation to time of day, and that shows maybe their some other patterns about, like, maybe they're a parent and they do a lot of things in the morning and then they sit down at an office desk, and you might find some interesting patterns there that you didn't expect. You just wanted to know how many steps they're taking each day. All right, moving forward to steps 3 and 4, if I can get my presentation to work. Formalize the concepts. So this is where you make all the concepts and processes explicit, formal, and both computer and human understandable. This is often known as pseudocode. So my classic example is trust is obviously quite a woolly, hand-wavy concept. But if you want to build a model, if you want to quantify trust, if you want to build a simulation or something like that, or put it into a game, you're going to have to define it in terms that computers will understand. So you might be a value between 0 and 100, or 0 and 1 if you want decimal points, or -1 and 1, or anything. It doesn't matter. It's up to you and how you want to define it. But you would probably also need to define it as a feature of an individual that has a particular target maybe, or it's between something that builds between two parties. So it might be an edge on a network graph, and the weight of that edge increases following mutually beneficial interactions. So you have to define, is it a feature of a single person? Is it a feature of a relationship? Is it, what is it? You would also need rules related to existing levels of trust decrease to zero if an interaction is deceitful, or they increase following a beneficial interaction. Now, we might not be used to writing in code, and that's fine. Pseudocode does not have to operate properly, but it does have to approach coding language, because either you or a collaborator, if someone else is doing the actual coding, needs to know what you're thinking about. So we, in the identify the problem stage, we might say, I want to study how trust changes over time as a result of interactions online. Great. But if you're going to do that through computational means, you actually need to define trust, you need to define interactions, you need to define all of these things in terms that computers can judge. This will be tricky if you've never done it before, and almost everyone will do a terrible ham-fisted job of it the first time they try. You'll get better with practice. You'll get better with people checking your work and making sure that they can understand what you've written. And yeah, it's a skill to learn. You also need to collect the data, implement the software, verify the software. So at this point, you start actually selecting the methods that you're going to do your research with. The choice of method will be highly dependent on your topic. So will you do an agent-based simulation? Will you create an app? Will you scrape websites? Will you download tweets through the Twitter API? These are all different methods. You have to decide based on your research question. So trust following social interactions, for example, might be through tweets and retweets, or liking tweets. So that might be, you might just say, right, that's the social interaction that I'm trying to capture. I'll capture it by downloading things through an API, and then I'll analyze it using some other software. So you want to thoroughly check that the selected method has been implemented correctly. And this is a very technical thing. Am I downloading the tweets that I want to download? Do I have the API configured to properly capture the people or the keywords or the timeframes that I want? Very mechanical questions at this point about, like, am I doing the thing that I think that I'm doing? This is, again, it depends on your research method. Okay, so we're taking another action break. So have it jot down in your notebook or mentally in your head. I recommend notebooks because it's always good to write things down. You learn things differently if you physically write it down. What would steps 3 and 4 of your hypothetical project be? Again, ask questions in the chat or the Q&A. Start your pseudocode writing. So who are the actors? What features do they have? If you want trains, for example, will you have the features might include capacity or top speed or current location, or these kinds of things. If your actors are train companies, you might have features like total staff, average pay, average length of employment. So maybe you're trying to identify whether poorly new or poorly trained staff lead to problems more than established staff. I don't know what your research question is, but start laying out and formalizing the concepts. Also have a think about how you might collect data, what software implementations you might do, what steps you might do to verify. Obviously, we're not in this few minutes action break going to collect the data or create the agent-based models or set up the API to collect data, but think about what you might want to do and how you would check that you've done it correctly. Just some ideas. It's all very, very rough and theoretical at this point. All right, got a little bit of stuff going on in the chat. Yes, quantitative social science research involves defining concepts and measuring in a quantitative manner. And fundamentally, computational social science will draw on a lot of quantitative social science concepts. So if you have quantitative social science background, you'll probably find it easier to step into computational social science, because we do have these steps about, like, how do you measure trust? How do you measure interaction? How do you plot trajectories of changing opinion? These are tricky, timey-wimey concepts, and it will be difficult to make them computational. There's not a right or a wrong way to do that. You just have to have a reason for why you've done it your way. Also be open-minded and willing to learn that there could be a better way. Again, that open-minded, willing to learn thing comes right back in, because everyone will get it wrong. There's an aphorism in sort of computer science that the best models are judged, or the way to judge a model's quality is by the speed at which it is replaced. So if something is useful, people will want to engage with it. They'll find all the problems with it. They'll be motivated to fix all those problems. So it will get better faster. And that's how you judge how good it is, not how perfect it was the first time, but how fast people are motivated to make it better. And that is a bit difficult for people who are historically used to getting it right the first time. That is potentially something that social scientists might need to unlearn. I don't know. That's quite existential. Maybe I've got that wrong. All right. There's no questions coming into the Q&A or the chat, so I will move on. You'll be surprised to hear to step 5. And in this one, you experiment and analyze data. So in step 4, you chose the methods that you would run your experiments on, or the methods you would use to analyze the data, or the methods you would use to collect and process the data. Step 5 is actually doing the thing. So run the experiments, build the models, analyze the data, otherwise use the methods that you've selected already. And you have to identify and explain the results within the context of the experiment itself. So you have to show the patterns in the output. You have to create visualizations about how numbers changed over time. You're not trying to understand the meaning at this point. You're just really analyzing what happened with the data, what happened in the experiment. All of these kinds of very statistical, nitty-gritty questions about the experiment itself. But step 6 is where you go beyond the results in the context of your data or your experiment, and you draw some conclusions about what it means. So does it support a policy recommendation? Who is affected by these results? Why does it matter? What should change now that we know about these results? Who benefits from that proposed change? And for that matter, who suffers from that proposed change? Because you're going to get a lot of kickback if you only paint your proposed change as a win-win. And in fact, if it's not win-win, there's always someone who loses out, and that person may or may not feel aggrieved. So this is where you relate the results of your experiment or your data analysis to your research question. This is where we start veering back into the social science, a sort of wheelhouse, because this is where we draw on background knowledge and sort of shared cultural values about why this is good or bad, or should we make these changes or not. There's a lot of shoulds here, and that's a social science thing rather than a computer science thing. Okay. Time for another action break. have a jot down of steps 5 and 6. Obviously, they're going to be quite abstract at this point. We don't know what the data shows because we haven't collected the data, but jot down what you think the data might show or what you hope the data might show, and also how that would matter for the original research question. So you might say, oh, the data shows that, people who rapidly gain trust following positive interactions are maybe at risk from catfishing or something like that. And therefore, a policy recommendation might be that we have to strengthen some laws about catfishing to protect vulnerable populations, something like that. Okay, got a question come in from Paula. Paula would like to evaluate the use of a new discovery platform that they're developing for go-triple.eu project. Paula is familiar with running individual usability evaluations, but my colleague will be gathering usage data via Mixpanel. I appreciate that some of these questions are not strictly CSS, but some aspects will be such that the interactions between users of the platform. Overall, the big question we'd like to answer is if the platform helps SSH research for more social science humanities, let me know, Paula, be more discoverable by both researchers and other stakeholders such as policymakers. Yeah, it is social science humanities. We have started thinking about individual KPIs that will be measurable, but after this, where do I start? Okay, this is great. This is, I think, a social science project, because what you're trying to do, your ultimate research question is, how do we make this research that can be hard to identify, hard to navigate, hard to understand, more accessible to people, and potentially on the expectation that making it more accessible has positive societal benefits. So it is a social science problem. And as long as you're using computational means to answer that question, so how do we get people engaging with the work on the platform? How do we get people maybe downloading or recommending or things like that? So your question specifically for this point is started to think about individual KPIs that will be measurable. Great. That's more or less step 2 or 3, sort of. So you're step 3, you're formalizing the concepts. After this, where do I start? Well, then you need to think about how people might achieve those KPIs. So if your KPI is we want researchers who've been on the platform for at least 6 months to have so many downloads or something like that of their papers, then you might start thinking like, how do we connect people to each other? How do we encourage downloads? Things like that. So you might start making pseudocode that says, if the download button is added to different kinds of pages, does that increase the downloads? If you change the color or the location of it, if you change how people can follow each other's research projects, if you add the option of email notifications or app sort of notifications, does that change the interaction? So without knowing more specifically about the project or the platform or, what the KPIs are, I'm just spitballing here. But yeah, you'd have to start asking questions like, if we want to achieve X, what steps do we think people might need to do X? So a lot about maybe different ways to view the information. And to that extent, I think you probably want to get in some expert interviews about how people take in information. You probably also want some accessibility things. So people who are visually impaired may not be seeing the buttons or reading the context in the way that you're expecting, and that might matter. I don't know how many social science humanities researchers have visual impairments, but I would assume it's not tiny. And maybe what rewards you give people on the platform for encouraging the behaviors you want to see. Do they collect badges? Do they get gold stars? Do they get promoted in some kind of ranking that everyone can see? These are all possibilities that you could think about. And again, there's no right or wrong answers. And if the project is about like, how can we do this, then expect to come up with like 9 wrong answers for every right answer. Maybe that's pessimistic. With good interviews, you might get 7 wrong answers for every right answer. So that's that question done. Yeah, and then arguably you do need to think carefully about the discussion and recommendations and conclusions. So like, why does it matter that we're getting people to achieve these KPIs? What's the benefit to the individuals? What's the benefit to society or to universities or to funding bodies? Depends on who's involved in this and what their rewards and costs are. You have to spell it all out as much as possible. Obviously, you'll never spell everything out. Somebody will show up at your conference presentation and say, you didn't consider my niche interest. Sorry, buddy. Yeah. Yeah. Oh, Paula appreciates the accessibility aspects. So yes, always consider accessibility if possible. Okay. Steps 7 and 8. 7, communicate, publish, present. So all of the previous steps, not just the results and the discussion and the conclusions, all of the steps need to be communicated to multiple audiences in multiple ways. So in the short term, you're probably going to be talking about methods. You're going to be talking with other social scientists. But in the longer term, you have to think about how you're going to communicate this to the public, to academic audiences, political audiences, students, all these different things. Not just conference presentations, but maybe blogs, white papers, society discussions, workshops, university classes. Like how, think big. Do you want to get published in Nature? Do you want your stuff to be taught in university classes? Think about your goals and what you want long term, as well as short term, like get this paper out by the end of the year, that kind of thing. And obviously, because this is all very theoretical and hand wavy, think big. Get it turned into a law. Why not? And finally, step 8 is share, document, validate. Now, this step is about how we make sure that the right thing was done. Previously, I think step 3, we made sure that we did the thing right. Here's we do the right thing was done by allowing your work to be studied, reproduced, modified as needed through openly available workflows, which is a description of the methodology, the steps taken, openly available code, openly available data, as transparent, well-documented, and openly available as possible. This is not always possible, obviously, for disclosure control purposes, but, as openly as possible. And this can be quite uncomfortable for people who've never done this kind of thing before, because workflows and steps taken, you do have to write down when you make mistakes, and you have to write them down in terms of how you noticed you made a mistake, what you did to correct it, what the long-term effects of that mistake are, maybe what things you learned, what changes you made, what things you will avoid in the future. That can be a bit uncomfortable, again, for people who were taught that they had to get it right the first time. This can be very grating. But if you really want people to use your method, you have to explain to them very clearly what to do, what not to do. And that involves being open about like, yep, we made that mistake 3 times already, and we only noticed it the last time. So, suck it up, make it available. So this is our final action break. Write down your ideal hypothetical steps for 7 and 8. So this might be a bit more fun. Imagine where are you going to get your stuff published? What audiences do you really want to hit? What kind of time frames? Do you want this to become like a landmark paper that exists for the next 100 of years and is highly cited? Dream big. Or is this just a step in a wider project and you think, we want to publish this in a conference proceedings, but something in the future that involves other things that we want to publish in the journal. Think about this a bit. Also think about how you will share, document, and validate your work. How will you show your thinking? What limitations do you expect from making it open? Do you anticipate there's any restrictions about whether you can make your code publicly available? Whether you can share all of your data, the raw data, the one that you've cleaned up to make it good for your analysis, the final output. Do you think you can make it all available, or will there be problems? Again, go ahead and chat in the chat or in the Q&A as you like. Okay, Wen has asked to identify in-demand skills from analyzing online job vacancy information. Any data source you could recommend? Yeah, you'd probably want to see if there's an API for like CV listing companies, so jobs.ac.uk if you want academic jobs. University web pages, they often have a job listing on individual web pages. You might need a web scraper for that rather than an API. Monster.com or Indeed or these kinds of big job boards. It kind of depends on who you want to target, academic jobs or industry jobs, and at what levels. But yeah, web scraping or APIs, I would think, for getting job listings. Joe has gone for lunch, like some kind of lunch eating person. I mean, I don't know, you all could be eating your lunch while you're listening to this, and that's fine. Don't worry about it. All right. There are a couple of final things to note, that these steps are not linear. I did cover this a little bit. Most, if not all, of the steps will require many iterations. So that is, don't expect to just start at step 1 and end at step 8 in a step-by-step way. You're going to go 1, 2, back to 1, 2, 3, 4, back to 2, 3, 4, 3, 4, 3, 4, 5, 6, back to 4, 5, 6, 7, that kind of thing. However, documentation, step 8, actually applies throughout the other steps. Do not wait until the end to start it. So there are tools that can make this much easier. If you have discussions with your colleagues on Zoom, you can enable transcripts, download the transcript at the end of the conversation and store that so that you have proof of when you discussed these topics, what conclusions you came through. Essentially, it's just taking good meeting notes during your meetings, but you can get transcripts if you want to sort of back that up. You'll want to learn as early on as possible to make your all the different steps available on collaborative sharing networks. So sort of VPN site, not VPN, SVN, which is subversion. It's a version control. GitHub, Open Science Framework, code repositories, data repositories, all of this. Make it as publicly available as possible. I mean, there is always a risk that someone will troll you and be like, oh, your code's messy. But typically, people are very helpful. They'll say, oh, I've noticed this error in your code, and here's how I think you want to fix it. Or I'm interested in this project, but maybe you could provide us with some sample data that we could use your code on. At which point, yeah, you think, actually, I could provide some sample data. Here you go. And then they get involved in your project. They give you good feedback. Yeah, so documentation all the way through, although the rest of them will have a lot of looping. Here are some references. So yeah, I did talk earlier about some books that you might read. So Speaking Sociologically with Big Data. So that is in sociology. Programming with Python for Social Scientists, The Turing Way. They have an online book that's all about reproducibility and open research. So if you're confused about what I'm talking about with code repositories, The Turing Way online book, excellent. We have The Dynamics of Computerization in a Social Science Research Team. So yeah, this is a case study about how social science research teams can get more into computerization and how that happened. And then Installing Computational Social Science, Facing the Challenges of New Information and Communication Technologies in Social Science. So as we see, I mean, one paper's from 1991, another's from 2016. The book was in 2019. This is not a brand new, fresh field, but it is a growing field, and it's becoming more and more important as technology improves and societal questions are really turning to face things that we can only address with computational methods.